Hello, Assalamualaikum. My name is Ahmad Fikri Fuad bin Mazani. Today I will present about our assignment for optical communication for BERT 4823. So now I will explain about the comparison of EDFA and SOA performance. So I will present about the overview. So the first erbium Doppler fiber amplifier use the active optical fiber Doppler with the erbium ions at the gains medium external up-arm laser 980 or 1480 nm as the ion to produce a population inversion. So we have a two a spectral target and a key strength. For the spectral target operates natural in a 1550 nm C-bands lower attenuations window, and then the key strength high gains and low noise figure the polarization independence and perfectly WDM compatible. And next optical amplifier, we use a semiconductor active region similar to laser diode without resonance and phase feedback, and we have a two key strength is extremely compact, low power consumption, cost effective and easy PIC integration. And two, for the limitations, higher noise figure, polarization sensitive and fast carrier dynamic causing non-linear distortions.
Okay, now I want to explain about design a system using a optic system. Simulation software to compare two amplifier, which is EDFA and SOA. Now we open the optic system. This circuit for EDFA, what component we use? Bit rate I setting for 10 mega. Then NLZ pulse. We have TW laser. I setting frequency for 1550 nm. Power 10 dB. We have match. Then optic fiber, I setting the length 50 km. With that, amplifier EDFA, setting with length 5 m. Then for the receiver, I use photodiode detector pin, low pass buzzer filter, 3R resolution. For the result, we can see BER analysis dengan eye diagram. Now we run. Okay, this is of the BER analyzer. You can see max detector 9.89239, minimum BER 2.21824. Okay, next, let's go to the circuit for SOA. The parameter just same. We just replace the EDFA to SOA filter amplifier. Now we run. Okay, we can see the max detector 2.4541 and minimum BER 0.0070611. If we use one circuit but we use two amplifier in the same time, this is our circuit. I just put another component which is WDM Dmax 2x1 1x2. So the length untuk fiber optic 50 just same length for both amplifier. Now we run it. Now for SOA BER analyzer, max detector 1.96 and BER we get 0 8.0215.899. For EDFA, we get next factor, the Q factor, 8.94845. Minimum BER is 1.5709.
Okay, this is result for SOA and this result for EDFA. The two figures show the clear performance difference between the SOA and EDFA optical amplifier system based on the eye diagram and BER analysis. In the first result, SOA, the eye diagram is more close and distorted, indicating higher noise signal interference and stronger inter-symbol interference. This is also supported by the low Q factor value and around 2.06 and higher BAR, which show that many bits error occur during transmission. This signal is now well spread between logic 1 and 0, making it difficult for the receiver to detect data accurately. In contrast, the second result EDFA show a much more open eye diagram with clearer signal separated. The Q factor is significantly high at around 60.26 and BER is extremely low, indicating almost error-free transmission. This means the signal is much better clear with less noise and distortion. Overall, EDFA provides a more stable and reality performance compared to SOA because it amplifies the signal more efficiently with lower noise contribution, resulting in better signal quality and transmission accuracy. Okay, next is performance result and metrics. We can see output power for EDFA link 3.3 dBm, SOA link negative 6.7 dBm. If EDFA has higher receiver power for the max Q factor, EDFA 16.2554, SOA 2.05856. EDFA offers superior eye clearly. Minimum BER for EDFA 9.6019 times 60 negative 60. For SOA 0.0170537. EDFA achieve error-free limit. For SNR, EDFA 62.62 dB. For SOA 28 dB. EDFA noise addition is vastly lower. For the power margin, EDFA 31.3 dB, SOA 21.3 dB. SOA has much smaller loss margin.
So for the summary, erbium dopper fiber amplifier EDFA achieve absolute superiority for the 80 km single mode fiber link, outstanding Q factor, low error flow, and the expressional signals integrity establish its definitive long haul standards, and the optical amplifier SOA usable for long distance trunk line due to high noise flow 28 dB and severe carrier induced signal degradation and low Q factor. For the practical guidelines, short deployments, EDFA is highly recommended for the standard long-range operation, where the high gain stability, polarization, independence, and robust link budget margin 31.3 dB are mandatory. For the alternative application, SOA remains available for short-reach local access network fast optical switching nodes for or integrate the photonic platform PIC, where a compact sizing and of course the primary driver. So thank you for our assignment.